Let's look at the big picture of how React.js works as a framework. We briefly touch upon some of React's benefits, the component structure, its dynamic features, etc., but let's get a little more detailed. As mentioned previously, React is a JavaScript web application framework. In web development, the typical architecture for a web application is the MVC pattern. In this pattern, a web app consists of its models, views, and controllers. Models are the core objects of the web app. By defining how models interact, the web app itself is defined and structured through application logic. The views are the presentational layer, what the user sees in terms of the document structure and formatted and interactive pages. Finally, the controllers are the layer which coordinates functionality between objects and views. They determine what data from the models get presented within the views themselves, and they respond to user input and interaction in order to update objects and call their behavior. Many web application frameworks have implemented this design and present a solution which hopes to take care of all three layers. React is often depicted as a kind of web app framework which merely takes care of the view layer. Now, it's true that React is mainly concerned with optimizing the presentation of UI in the main web applications document. But that's an oversimplification of what React's component structure truly achieves. React achieves the view layer certainly, but it does so much more. React's main benefit is the ability to split up your application into multiple reusable components. The components define their own HTML-like structure that allows a user to create a presentational section of the web page. These components can be plugged in anywhere into a web app. So this means that your web app can consist entirely of React components. Or React can even be inserted into one or two spots within your existing application. That way it can help take care of some dynamic functionality. A great thing about components is that they all maintain their own internal state. This is a data structure which continually updates as the user interacts with the component throughout the web app. For example, there can be a title field which updates while the component is interacted with within the application. Based on how this state updates, the component will determine what text and elements to present to the user. Another key feature of React are their lifecycle methods. Lifecycle methods fire at different phases of a component's life throughout the web application. To truly appreciate how lifecycle methods work, we're going to need to go into how the core document and the virtual DOM of React work. And we're going to do that in just a second. But as a quick definition, lifecycle methods allow you to fire code, for example, when the user first loads a component and when the user leaves a component, or just after the user has completely loaded the component. They're very useful for making API requests, for example, that need to fetch data from a backend to present to the user at different phases of a component's interaction. So again, to truly appreciate lifecycle methods, we need to discuss one of the other core innovations of React, which is the virtual DOM. The virtual DOM is an in-memory version of the entire web applications document that React uses to efficiently update the application's presentation. It's maintained under the hood by React's engine, and it looks almost exactly like the actual document for the web page. The reason why React maintains an internal virtual DOM is to approach a common concern between all web apps in their frameworks. You see, nearly all web frameworks and web apps are concerned with updating the core JavaScript document that is provided in the browser environment. Notice that this document, again, looks exactly like React's virtual DOM. In fact, it's more accurate to say that, well, React's virtual DOM tries to mimic the original browser document. This document object provided by the browser is very powerful. It provides methods and APIs that allow you to programmatically update the core HTML of the web page and therefore update what the user is seeing. The only problem is that using these methods too often and too frequently can be a little slow when it comes to application performance. Therefore, React builds a virtual DOM to offload updates until it can figure out an efficient set of methods to run an update through this actual document structure. This is why React is so much more than a view layer. It's a full-on presentation engine. Now, this idea of a document gives us further insight into how the lifecycle methods in React are actually implemented. They mainly center around the idea of a component mounting onto the DOM. So a component will mount onto the document object model of the browser. For example, say we have an app component. When React inserts this component into the document to appear for the user, this is called mounting onto the DOM. We can capture this event in code with a lifecycle method called component_did_mount. And then later, if and when React decides to remove this component through logic from the document, well, this lifecycle event is now unmounting from the DOM. This event is captured through a method called component_will_unmount. Mounting onto the DOM is an event that is equivalent to the React's component HTML-like structure being inserted as elements in the web page. And unmounting is that HTML-like structure being removed. Okay, that's an overview of how React works as a framework. Next, let's briefly touch upon how React is incorporated itself into a web app in terms of code and files. Recall that a web page is at the core an HTML document sent from a server to the browser. This HTML, as the structural code, can be accompanied by a JavaScript file to enable dynamic functionality. React is implemented completely in JavaScript. Therefore, in order to serve up React in a web page, in a web app, the way to do it is to send your React code in a JavaScript file along with the HTML. Now, the main challenge comes in presenting all of your React code as a single JavaScript file. Now, technically, a browser can handle multiple JS files, but the browser doesn't have a system of importing and exporting code between JavaScript. It loads the code for one file, and then one at a time loads the other ones as if they're sharing all the same file. This makes it confusing as multiple independent sources of JavaScript can more often than not be more confusing and cause painful naming conflicts. But this is a further issue because a React project itself is split up into multiple directories and files to sensibly organize the application. However, how are we going to get all these files into the browser? Do we send them all separately? Again, this wouldn't be ideal due to the browser lacking the concept of imports and exports. Really, what we want to do is to send all the React application code in one overall file. Therefore, as a solution, we have bundlers. Bundlers are a technology which will take care of packaging all of your separate React code and files into one overall mega JavaScript file. This packaged JavaScript file will even include the source code for any libraries and dependencies the React project might be using. Another convenient feature of bundlers is that they often contain transpilers. Transpilers allow you to code with modern features of JavaScript that have not been fully supported yet in all browsers. When it comes to compiling the overall JavaScript file, the transpiler will step in for any modern syntax and then substitute a functionally equivalent older JavaScript version of the code for that newer syntax that the browser can handle. For our bundler and transpiler, we're going to use a technology called Parcel Bundler. It's a really quick and very fast bundler, so it's really nice. You may have also heard of Webpack, but ever since I tried Parcel, it's been my go-to option for bundling React projects because of its very fast performance, clean output, and very quick configuration. Alright, that completes a React overview, how it works as a web framework, and how its code will get included within a web application. So with that, let's start building a React web app.